Good evening, students. Very good evening. How are you? Give me the clearance with regard to audibility and visibility, please. Am I audible and visible? All good. Very good. Hello. Very good evening again. Welcome back to PW platform. Algorithm crash course और आज की topic है dynamic programming. Yes. Thank you very much for the response. Yes. Very good evening to again all of you. तो आज का सेशन स्टार्ट करते हैं. जैसे मैंने लास्ट क्लास में बताया था कि we are going to begin our discussion with the important topic of algorithms, that is dynamic programming, जिसे जनरली हम इंडस्ट्री में या रेगुलर इंस्टीट्यूशंस में जनरली शॉर्ट में बोलते हैं डीपी. देखिए, डायनेमिक प्रोग्रामिंग अज्यूम्स इंपॉर्टेंस नॉट ओनली फ्रॉम गेट पर्सपेक्टिव. ये देखिए, इट्स नॉट जस्ट इंपॉर्टेंट फ्रॉम गेट एग्जाम, लेकिन डायनेमिक प्रोग्रामिंग इज ऑल्सो इंपॉर्टेंट फ्रॉम द पर्सपेक्टिव ऑफ योर प्लेसमेंट्स. अगर आप लेवल 1 कंपनीज के लिए प्रिपेयर कर रहे हो या टॉप लेवल सर्विस बेस्ड कंपनीज के लिए प्रिपेयर कर रहे हो, तो जनरली देयर इज अ वेरी गुड चांस दैट यू मे बी पुट क्वेश्चंस, प्रॉब्लम, कोडिंग प्रॉब्लम्स फ्रॉम दिस डोमेन ऑफ डायनेमिक प्रोग्रामिंग. So in that regard, in all aspects, I would say essentially dynamic programming is a very, very important design strategy. Generally, it is observed that the students have a bit of confusion with regard to this, so I will try my level best. Even though ये एक crash course है, we will try our level best to lay the foundation so that ये foundation के basis पर आपके concepts not only clear हों, but also you should be able to work out the problems. Yeah, Neha Mishra, good evening. Rahatullah, Tushar, very good evening to all of you once again. So first my objective, मेरा जो objective है पहले मैं आपको बता दूंगा कि मैं ये बताऊंगा कि व्हाट इज डायनामिक प्रोग्रामिंग, हाउ प्रॉब्लम्स आर सॉल्व विद डायनामिक प्रोग्रामिंग, हाउ इज इट डिफरेंट फ्रॉम डिवाइड एंड कॉन्कर, हाउ इज इट डिफरेंट फ्रॉम ग्रीडी मेथड, एंड व्हाई प्रॉब्लम्स solvable, I mean, are not solved, optimization problems are not solvable with the greedy method, and how they can be solved with dynamic programming. फिर उसके बाद हम देखेंगे कि what are the elements of dynamic programming, components of dynamic programming, approaches of dynamic programming. आपको पता होगा we have approaches like what we call memoization, bottom up, top down, top down memoization technique and bottom up tabulation technique. So ये दोनों methods भी हम देखेंगे with some good number of problems. Some case studies जो हम देखेंगे like MSG problem है, multistage graph है, longest common subsequence है, Fibonacci है. उसके अलावा फिर और अगर टाइम परमिट करा तो then we will at least define some problems and their approaches for formulation of the dynamic programming recurrences for solving the problems. ये सब देखेंगे हम. Yeah. So first point I would like to make a mention here. If you, again I will write the topic here so that there is no confusion. Just for information purpose, I would like to tell you that the concept of dynamic programming or the paradigm of dynamic programming, the design strategy of dynamic programming was proposed by Richard Bellman way back in 1950s when he was working in some US based company by name Rand Corporation. Actually he was working on solving some mathematical optimization problems. So it happened that while solving those problems he gave this paradigm, important paradigm, which became very essential and very important, particularly in the software industry, called dynamic programming. So first point I would like to make a mention with regard to this is a design technique used for solving problems whose solutions, मतलब जो प्रॉब्लम सॉल्व कर रहे हो उसके सॉल्यूशंस, whose solutions are viewed as a result of making a sequence of decisions. The first point you should keep in mind. मतलब ये बताना चाह रहा हूं कि any problem, right? Yeah, but top down and bottom up both. Tushar Sisodia. Any problem that needs to make a sequence of decisions, whose solutions are viewed as a result of making a sequence of decisions, we can think of solving such problems using dynamic programming. लेकिन if you remember, I don't know whether you remember or not, हमने यही statement greedy method में भी लिखा था, same as it is. Greedy method is also used for solving problems whose solutions are viewed as a result of making a sequence of decisions. मतलब कोई भी प्रॉब्लम हो, अगर उसके सीक्वेंस ऑफ डिसीजंस आपको you have to make the sequence of decisions, right, as part of its solution, then such problems can be solved using greedy method also. लेकिन फंडा क्या है? So that's what in the second statement I will write. For some problems, these sequence of decisions, I'm writing in short, these sequence of decisions are made in a stepwise manner and never making an erroneous decision. So this is true. That means this approach or this strategy, this is true for problems solvable by dash technique. यहाँ पे आपको dash fill up करनी है. Come on, देखिए आप पढ़िए statement. I'm saying that please follow. I'm saying that for some problems, if not all, these sequence of decisions जो आपको बनाने हैं, these sequence of decisions can be made in a stepwise manner, step by step, by applying the principle of local optimality in a stepwise manner. So this approach is true for problems solvable by dash technique. Which technique? कौन सी technique से? This statement is true, holding true for which technique? Come on. For some problems, we can arrive at these sequence of decisions by making the decisions in a stepwise manner, right? And never making erroneous decisions, by appealing to the principle of local optimality. So this is true for problems solvable by dash technique. Fill up the dash. ये dash क्या होना चाहिए? Not recursion. Which strategy makes stepwise decisions? By applying to the principle of local optimality. Come on, not recursion, not optimal. No, Naveen Kumar, Neha Mishra, it is not recursion, neither optimal. This is true for problems solvable by dash technique. कौन से टेक्निक में आप stepwise decisions लोगे और arrive at optimal solutions? In which technique? Greedy method. This is true of greedy technique, is it not? Many problems like job sequencing with deadlines, greedy knapsack हो या Huffman coding हो, optimal merge patterns है, right? Optimal storage on tapes है, minimum cost spanning tree, single source shortest path, many problems. This is true for problems solvable by stepwise. We can arrive at optimal solution by making stepwise decisions. Like in greedy method, by applying to the principle of optimality. Like in, here I am writing with a different ink. For many other problems, and when I say problem, the problems may be optimization problem, the problem may be what we call non-optimization, जिसे हम बोलेंगे decision problem. For many other problems, making stepwise decisions or taking stepwise decisions does not yield मतलब giving the output, does not yield optimal solutions. For many other problems, making the decisions in a stepwise manner by applying local optimality principle does not yield optimal solution, does not give you the final optimal solution. ठीक है, feasible हो सकता हो, but may not be optimal, and we want optimal solution because the problem may be optimization problem. अब आप बोलेंगे कि कौन से problems है और कैसे prove करेंगे? I give some examples here for examples. Next slide you can check. Not working. Look at this. The first problem which I am taking into consideration is this. I want everybody to have a look at this. A problem which I have written here by name coin change problem. I would like you to read, perhaps you might not have encountered this problem earlier, you might not have encountered, so I would appreciate if everybody have a look at this. Have a look at this problem and then we will discuss. Because I said that for many problems, like maybe coin change or maybe you can say multistage graph, which I am going to define next, making decisions in a stepwise manner by appealing or applying the principle of local optimality does not help. So I would like you to please have a look at this problem definition. Given a set of coin values, we are required to construct a target sum money, using as few coins as possible. You can use each coin value any number of times. ठीक है, हमारे पास कुछ कॉइन्स है, कॉइन वैल्यूज है, जैसा 5 रुपए का कॉइन है, 10 रुपए का कॉइन है, इसी तरह 1 रुपए का, 2 रुपए का कुछ कॉइन वैल्यूज है, n कॉइन वैल्यूज है, और एक टारगेट सम मनी है m. We need to construct that target sum money using as few coins as possible. As few coins as possible. एक कंडीशन ये दिया गया है कि you can use a particular coin any number of times. हमारे पास काफी infinite instances है coins के. Like for example, take the first example. Suppose the target sum money is 12. I want to make a target sum money of 12. And the available coins are values 1 to 5. 3 coins है जिसकी values है 1 रुपया है, 2 रुपए है, 5 रुपए है. इसके कई instances available है, कई instances. तो मैं यहां पर आपको यह पूछ रहा हूं, let me see who will answer this question. If I work out, if I solve this problem using greedy method, please observe. If I solve this problem using greedy method, what is the solution that I am going to get? Come on, tell me. अगर मैं greedy method से solve, already by this time you know what is greedy approach. Greedy कैसे वर्क करता है आपको पता है. So using greedy method, can you please tell me what will be the optimal solution for this problem? Minimum number of coins चाहिए आपको. So कौन से denomination के coins हम ले ताकि I will get my desired solution. That I want a target money of 12 using coin values of 1, 2 and 5. What is the optimal solution that are we going to arrive at this? Come on, boys and girls. Tushar, Rohit, Neha Mishra, Prashant Prabhakar, Naveen Kumar, please tell me what is the answer for this? Greedy approach. तो greedy में हम क्या करेंगे? We want less coins, as few coins as possible. तो मतलब हम पहले कैसे, पहला स्टेप क्या होगा हमारा पहला स्टेप होगा take that coin which is of highest denomination and as many as possible. यहां पर हमारा highest coin value of 5, right? तो मैं जितना मेरा टारगेट सम मनी है 12, सो मैं 3 तो नहीं ले सकता, 2 ले सकता हूं. 5 + 5 10. अब उसके बाद देखिए आप नेक्स्ट हाईएस्ट कॉइन वैल्यू है 2. क्या हम इंस्टेंस ले सकता हूं? हाँ, अगर मैं 1 ले लूं तो मेरा डिजायर्ड ऑब्जेक्टिव आ जाएगा सम. So therefore the answer for this is 3 coins. 2 of 5 and 1 of 2. Greedy method works. और आप ये भी देखिए कि ये प्रॉब्लम इंस्टेंस में, प्लीज बॉयज एंड गर्ल्स वेरी केयरफुल, यहां पर आप देखोगे कि greedy method is working and this is the optimal solution also. This is optimal solution. Is it not? This is optimal solution. इससे और बेहतर solution नहीं हो सकता. I can't have any other solution. So I say that greedy method is working for this problem instance. Yes, Neha Mishra, you are right. We'll start with highest coin value and take as many instances as possible, just like your knapsack. Knapsack की तरह आप देखिए. These like knapsack capacity. These are like objects. You try to fill up with the highest profit object, like if you consider this as highest profit, like that you are thinking. So what I'm trying to say, that greedy method is working out for this problem instance. अब मैं ये चाह रहा हूं, you take the second problem instance here. Come on, boys and girls. Second problem instance. Like I'm taking a target sum money of 6. Target sum money of 6. And the coin values are 134. Coin values are 134. अब यहां पर आप बताइए, for this data set, using greedy method, very important. Using greedy method, what is the solution that is going to be reported? Come on. अगर मैं ग्रीडी स्ट्रैटेजी अप्लाई करूंगा, जो आपने पिछले बार बताया था, वही ग्रीडी स्ट्रैटेजी लेकर हम इस प्रॉब्लम इंस्टेंस को सॉल्व करेंगे, तो हमारा क्या सोल्यूशन आएगा? क्या सोल्यूशन आएगा बताइए फॉर दिस प्रॉब्लम इंस्टेंस, सेकंड प्रॉब्लम इंस्टेंस. कम ऑन, कम ऑन, कम ऑन. कपिल अग्रवाल, एब्सोल्युटली राइट. तो इफ आई अप्लाई ग्रीडी स्ट्रैटेजी, तो क्या होगा? हाईएस्ट डिनोमिनेशन कॉइन इज 4. 2 तो नहीं ले सकता हूं मैं, 1 ही लूंगा. फिर उसके बाद नेक्स्ट हाईएस्ट डिनोमिनेशन 3 नहीं ले सकता, बिकॉज माय टारगेट सम मनी इज 6, राइट? सो देयरफॉर आई विल हैव टू टेक लाइक नेक्स्ट हाईएस्ट डिनोमिनेशन 1 + 1, 2 coins, 6. So therefore 3 coins are needed, right, as per greedy method, as per greedy method. लेकिन क्वेश्चन ये है, इज दिस ऑप्टिमल? क्या ये ऑप्टिमल सोल्यूशन है? बताइए. ग्रीडी मेथड इज रिपोर्टिंग दिस. Take coin of 4 and 2 1 rupee coins to get a sum of 6. Is this optimal? No, this is not optimal. इसका optimal solution क्या है, please? We don't know how to apply, but the data set is very small. You can look at the data set and tell how to get. That is a different matter. Optimal solution, everybody you can say it is 3 + 3, 2 coins. So what should I conclude from this example? Come on, boys and girls, what should I conclude from this? What should I conclude from this? Come on, लिख के बताइए, what should I conclude? हमारा कंक्लूजन क्या होना चाहिए बेसिस पे? ये प्रॉब्लम इंस्टेंस के लिए ग्रीडी मेथड हैज वर्क, बट व्हेन आई टेक अनदर प्रॉब्लम इंस्टेंस, ग्रीडी मेथड इज फेलिंग. सो देयरफॉर वी कंक्लूड दैट greedy method fails for this problem. For this instance, greedy method fails. एक इंस्टेंस के लिए वर्क कर रहा है, दूसरे इंस्टेंस के लिए वर्क नहीं कर रहा है. अगर आपकी स्ट्रैटेजी, ग्रीडी स्ट्रैटेजी अगर ऑप्टिमल होती, अगर रियली करेक्ट होती, तो यू वुड हैव वर्कड ऑलवेज करेक्टली, बट हियर इट इज फेलिंग. तो इसका मतलब यह है, कॉइन चेंज प्रॉब्लम कैन नॉट बी सॉल्व यूजिंग ग्रीडी मेथड. वही पॉइंट मैंने पिछले स्लाइड में लिखा था आपके लिए. Just a second, I will reorder it. This is the point I have written here. For many other problems like coin change and many like 0-1 knapsack, traveling salesperson, multi-stage graph, I am going to show for multi-stage graph. Making stepwise decision does not yield optimal solutions. Like step 1, you wanted the problem with highest denomination. That is not going to work out. It is not fair. It is not working. For many other problems, making decisions stepwise by appealing to the principle of optimality does not give optimal solution. So greedy method has failed. Coin change problem cannot be solved using greedy method. अब और एक प्रॉब्लम लूंगा मैं, जिसका नाम है मल्टी स्टेज ग्राफ. यहां पर भी हम देखेंगे. दिस इज अ वेरी इंटरेस्टिंग प्रॉब्लम. Related to graphs now, related to graphs. Problem is called multi-stage graph. तो पहले हमें define करना होगा what is multi-stage graph. Generally we write in short MSG. We write in short MSG. Like any other graph, listen, like any other graph, the multi-stage graph is also defined in terms of set of vertices and set of edges. If you believe that the number of vertices are n and the number of edges are e, there are n vertices and e edges. The vertices of the graph are placed in stages. Please observe. The vertices of the graph are placed in stages. Stage 1 has 1 vertex. Stage 2 has 4 vertices. And stage 3 has 3 vertices. Stage 4 has 3 vertices. Stage 5 has 1 vertex. So first and the last stage always have only one vertex. First and the last stage will have a single vertex. The remaining n minus 2 vertices are distributed in the remaining L minus 2 stages. So I assume that the graph is a L stage graph. The graph is a L stage graph. Okay? The graph is a L stage graph. So this is the distribution of the vertices in the stages. First stage and last stage will have a single vertex. In between the remaining L minus 2 stages will have the remaining n minus 2 vertices. And generally, we also have restriction on edges. Generally, in a graph, I can have an edge from any vertex to any other vertex, is it not? In general, any graph में, कोई भी graph में, आपके पास कोई भी vertex से कोई भी other vertex को edge होगा, लेकिन multi-stage graph में उस तरह नहीं है. I will have a connectivity from vertices present in stage 1 only to stage 2. देखिए आप, connectivity मतलब edges. Stage 2 vertices can only be connected to stage 3 vertices. मतलब vertices that are present in stage I will be adjacent to only vertices present in stage I plus 1. Very interesting. Please follow carefully. Vertices that are present in stage I will only be adjacent to vertices present in stage I plus 1. Vertex 1 can never be adjacent to vertex 6. हाँ, path हो सकता है, that is a different matter, but not edge. Right? The graph is generally a weighted graph. The graph is generally a directed graph. Undirected भी हो सकती है, but most of the time it is a directed weighted graph. ठीक है. There are many applications of branches of engineering like civil, mechanical, which are modeled based on multi-stage graph. कई problems है engineering के that work on the principle of multi-stage graph. लेकिन हमें यहाँ पर determine क्या करना है? What are we supposed to do? It's a single pair shortest path problem. It's a single pair shortest path problem. Shortest path problem. Single pair shortest path. We want to find the shortest path from vertex S present in stage 1 to vertex T present in last stage. Vertex S present in stage 1 to vertex T present in last stage. Here we have an interesting aspect. We have a very interesting aspect. So please observe. What I want you to do now, please follow me, that I want you to apply greedy method. I want you to apply greedy method and tell me what path greedy method is going to report using or for this multi-stage graph from S to T. Come on. You know the principle of working of greedy strategy. By applying greedy strategy, can you tell me what path will be reported by greedy method? Greedy method works in a stepwise manner. At every step out of available option, greedily select that option which satisfies your objectivity in addition to satisfying feasibility criteria. So if you apply greedy method, what path will be reported by greedy strategy? Can you report to me in the chat box? क्या आप बताओगे मुझे chat box में? Come on. What path will be reported by greedy strategy? Yes. Ratul answer. Yes, many people, very so simple. We are starting from 1. So we say that naturally out of all the possible options available like 9, 7, 3, 2, obviously I will go to 5. From 5 there are 2 options, 11 and 8, so I will go to 8. From 8 there are 2 costs, 5 and 6, so obviously I will go to 10. And from 10 there is no option other than going to 12. This is the path reported by greedy method. And what is the cost of this? Iska cost kitna hai? What is the cost of this path? 1 to 5, 5 to 8, 8 to 10, 10 to 12. What is the cost of this path? Come on, come on. The cost of this path is 17. Cost of this path is 17. The question is, does there, listen to this question, boys and girls, does there exist any other path? क्या कोई और path है इस graph में whose cost is less than 17 and is able to reach from S to T? Is there any other path in the graph which has a cost value less than 17 and you are able to reach from S to T with that? अगर कोई हो तो बताइए मुझे what is that path? Does there exist an alternate path in the graph that connects S and T with a value less than 17? क्या कोई path है? Because you can, graph is not that big, you can just look at it and tell me. Does there exist a path? क्या कोई path है इस graph में whose cost value? Yes. You can, like for example, if you look at this path 1, 2, 7, 10, 12. 1, 2, 7, 10, 12. These also are a path. I don't know how I got, we will see that later point of time, right? But what is the cost of this path? Come on, what is the cost of this path? Yes, 16. Rahul Kumar is saying 16. So what does this mean? This also means that this particular problem of multi-stage graph cannot be solved using greedy method. So therefore the conclusion is again the same thing, that greedy method fails. So I'm just trying to illustrate, I have not yet introduced dynamic programming. I'm just trying to make you understand that for few optimization problems, for example, which I have taken like coin change problem and multi-stage graph, I'm just trying to prove that greedy method does not work for these optimization problem. मतलब जो strategy है greedy की by making stepwise decision by appealing to the principle of optimality does not work for many problems like these multi-stage graph, coin change, 0-1 knapsack. उसी तरह problems like traveling salesperson, and the list continues. List continues. It does not work. Now the question is, हमें देखना ये है कि why greedy method has failed. Can anybody tell me? Can you write down in the chat box why greedy method has failed and what is alternate for it? What are the alternate solutions for this? Greedy method has failed, ठीक है. What are the alternate solutions to get the optimal solution of this? What is the approach? Alternate solutions. Come on. Alternate solutions. The immediate alternate solution, I am very sure you can identify. What is the immediate alternate solution for greedy method which has failed for this? Come on. What should be the alternate solution if greedy method is failing for it? Yeah, dynamic programming, branch and bound, that is okay. Because I have not, yeah, exactly correct. Mac is saying try all paths. What do you call that strategy, Mac? You're saying try all paths. In this, you try all paths, enumerate all paths, and then pick up the best. What do you call that strategy as? Brute force. Very correct. So the alternate solution is brute force. Please, I'm building up the foundation for dynamic programming. Follow me carefully. Brute force. The brute force approach is also called enumeration. It is also called enumeration strategy. List out all possible paths and then pick up the best. This will always give you optimal solution. ये हमेशा correct रहेगी approach. लेकिन क्या मुझे बताएंगे, कोई लिख के बताएंगे कि what will be the drawback of solving problems with enumeration or brute force? Come on. What will be the problem? Yes, Kapil Sharma, you're right, brute force. लेकिन क्या आप लिख के बताओगे कि what may be the drawback if I solve the problem using brute force? Enormous. The drawback will be enormous. Time and space requirements, time and space complexities. The drawback of brute force will be enormous time and space complexity. Generally, this will be order of exponential times, brute force, for most of such problems. So that's why we don't prefer, right? So we go for a strategy next, which is called dynamic programming. We write in short DP. Essentially based on brute force. That means it evolves based on brute force, but it tries to curtail what are the important characteristics of dynamic programming with which you will be able to reduce the time complexity from exponential maybe to polynomial, right? So there are two aspects. One is it will try to curtail. Curtail means cut off those decision sequences from where there is no possibility of getting optimal solutions. is one aspect of dynamic programming. Based on enumeration, but it will cut off those decision sequences from where there is no possibility of getting optimal solution. That way it will try to reduce the brute force. Second aspect of dynamic programming is, it is going to store, right, in a table perhaps, the results of subproblems. Right? Generally those subproblems you call it as overlapping subproblems. अभी बताऊंगा मैं मतलब इसका by taking a suitable example. Results of subproblems, so as to avoid, we will write, so as to avoid recomputation. These are the two important characteristics. Memoization बोलते हैं उसको. Tabulate or memoize the results of the subproblem so that we can reuse rather than recompute. These are the two aspects, two characteristics basically, which is going to minimize the time complexity in comparison to the traditional brute force or traditional enumeration strategy. So this is the basic notion of dynamic programming. अगर आप यहाँ पर देखेंगे फिर multistage graph में, see, जो मैं important point highlight कर रहा हूँ, and based on that there is a small motivation for you also for your gate preparation. Like stage 1, we are at stage vertex 1 in stage 1, please follow. By greedy method you immediately opted for this path, right, 1 to 5, without bothering, listen to me carefully, without bothering whether the resulting sequence of decision, जो बाकी के जो decisions होंगे ना, from 5 to 12 जो बाकी के decisions होंगे, बाकी का जो sub path होगा, greedy method does not bother whether will that be optimal or not. Greedy method does not bother. It only say that at the current state and available options, which is best, that will I will opt for. I don't care the resulting cost of the path, sub path from 5 to 12, will it be optimal or not, greedy method does not bother. और ये पर देखिए आप, ये sequence 9, this cost value is 9, highest among all. But the overall sequence of decisions from 2 to 12 relatively is having lesser cost than in comparison to 5 to 12. That's why this is coming out to be of minimum cost. So greedy method does not talk about the concept of remaining sequence of decisions, remaining cost of the subpath, जिसे हम बोलते हैं optimal substructure property. Greedy method does not bother. सानी टेक्स्ट बुक के कन्वेंशन से हम उसे बोलेंगे प्रिंसिपल ऑफ ऑप्टिमैलिटी. Greedy method only say that whatever my current state and available options are, greedily select that option which satisfies my objectivity, without bothering whether the remaining cost sequence of decisions, will they be optimal or not. Greedy method does not bother. Whereas dynamic programming say that whatever initial state and your first decision is, the remaining sequence of decisions should also be optimal. That is what is needed in the strategy, and that is what is used in dynamic programming. Dynamic programming makes its sequence of decisions by appealing to the principle of optimality, and as per common convention, that is called optimal substructure property. Principle of optimality. Principle of optimality or optimal substructure property says that whatever the initial state and decision are, the remaining sequence of decisions must be optimal with regard to the state resulting from the first decision. इसके लिए जनरली एज ए सॉर्ट ऑफ मोटिवेशन मैं स्टूडेंट्स को एक एग्जांपल देता हूं. दिस इज जस्ट लाइक योर करियर पाथ. चूंकि आप लोग तो पूरे गेट एग्जाम के लिए प्रिपेयर कर रहे हो, तो ठीक है. जनरली मैं जब क्लास में स्टूडेंट्स को बोलता हूं विथ रिगार्ड टू करियर ऑप्शंस, देयर आर 2 करियर ऑप्शंस, राइट. वन इज जॉब एंड द अदर इज हायर स्टडीज. अब जॉब में भी आप देखिए 2 ऑप्शंस है और हायर स्टडीज में भी 2 ऑप्शन है. प्लीज अंडरस्टैंड, दिस इज अ वेरी गुड एग्जांपल आई जनरली कंसीडर. You may appreciate or not, that is a different matter. Consider this. Jobs, again there are 2 options. Prepare for service based companies, prepare for product based level 1 companies. और higher studies में भी 2 options है. Prepare for GATE, prepare for MS abroad like US, UK, Canada, Australia, New Zealand, etc. ठीक है. तो जनरल टेंडेंसी जो होती है स्टूडेंट्स की, जो मैंने देखा है, दे ऑप्ट फॉर इजी अप्रोच. लाइक whenever I say, I mean they say ठीक है भाई, अगर level 1 product based companies के लिए prepare करना है, तो I have to prepare all the subjects, I have to be very strong in my subjects, ठीक है. लेकिन अगर सर्विस बेस्ड कंपनीज के लिए, मैं आई एम नॉट टेकिंग एनी नेम्स, सर्विस बेस्ड कंपनीज के लिए अगर प्रिपेयर करना है, देन आई डोंट हैव टू बी वेरी स्ट्रांग इन सब्जेक्ट्स, एवरीबॉडी नो. अगर आपके पास एप्टीट्यूड हो तो कुछ एप्टीट्यूड हो, राइट, क्वांटिटेटिव एप्टीट्यूड, न्यूमेरिकल एप्टीट्यूड, एंड देन सम सॉर्ट ऑफ बेसिक प्रोग्रामिंग का एक्सपोजर हो, सम प्रोग्रामिंग प्लेटफॉर्म, so that is sufficient enough to get absorbed in such service based companies. So you don't have to prepare for it. It is just like taking this path. Preparing for service based companies is like taking this path. Preparing for GATE is taking this path. Preparing for product based companies is taking this path. Initially you have to put a lot of effort. लेकिन जब आप गेट के लिए प्रिपेयर करोगे, rather than MS के लिए भी क्या है, you have to write IELTS, you have to write GRE at most and get through. You don't have to bother about your subjects. ठीक है, easy path initially. लेकिन उसके बाद की जो hurdles होंगे, we don't know. जैसा अगर आपने अपने आप को एब्जॉर्ब कर लिया, आई एम सेइंग 90%, आई एम ignoring 10%. 90% of the people who get placed in service based companies will have to definitely face the heat in their career at later point of time. इसीलिए मैंने देखा कई ऐसे स्टूडेंट जो सर्विस बेस्ड कंपनीज में जॉब किए हैं 4 years, 5 years, 8 years तक भी, then they came for GATE coaching. मैंने पूछा क्यों? सर, फ्रस्ट्रेशन, no career development, no career growth, nothing. Most of the time we are on benches, and then the type of job is only basically like troubleshooting and all that. There is no growth, sir, at all. Why? Because you have opted for this path. You have not opted for this path. लेकिन अगर आप initially at this stage, if you put this effort of 9 subjects you have to prepare like GATE or maybe for product based companies, ठीक है, initial अगर आप effort डालोगे और अपने आप के लिए गेट, आई मीन IIT के गेट्स ओपन कर लोगे, ISC के गेट्स ओपन कर लोगे, then after that, believe my students, I don't have to tell you that you don't have to worry about your career. लेकिन आप सर्विस बेस्ड कंपनी ज्वाइन करोगे या MS एक लोकल यूनिवर्सिटी में कर लोगे MS, then you definitely will have to basically take it as a challenge for your remaining part of your career. Always that thought will be wandering, hounding in your minds. Okay, what will happen after that, right? So this is like, I would say, greedy approach and dynamic programming. Right? This is just like greedy approach and dynamic program. So I would always suggest my student, don't be greedy about with respect to career. Okay? Yes, some student right now is commenting, I left service-based company. Many students I have seen in my teaching career, service-based companies छोड़ रहे हैं और आ रहे हैं, because they realize later point of time. So my dear students, जो भी time अभी बाकी है आपके पास, you put your 100%. Put the effort. This is the path you have to channelize yourself. Initially आपको mistake थोड़ा hurdle होगा. I'm not saying you do right GATE. I'm saying you prepare your subject, be strong in your subjects, right? Put the initial effort so that later point of time you reap your fruits. You don't have to bother about careers. हाँ, आप जाइए, जरूर जाइए MS करने के लिए, मैं ये नहीं कर रहा हूँ MS, but do in good university with good stipend, good assistantships, etc. So that later जब आप वापिस भी आना चाहो back to India, then you should have scope and opportunity to get opportunity to work in good companies. ऐसा ना हो कि आप एक कुछ एवरेज यूनिवर्सिटी से MS किए और फिर यहाँ पे आके आप सफर हो रहे हो, ऐसा ना होना चाहिए. तो इसलिए think well, take wise decisions, put initial effort. जो आप एफर्ट डालोगे गेट के प्रिपरेशन के लिए या सब्जेक्ट्स के लिए, that will never go waste. That is what I wanted to say. So this is my small contribution to tell you the distinction between greedy method and dynamic programming. यही difference है. Sometimes greedy method works. थोड़े candidates जो working in service-based companies at top level, okay, they may be doing well. This is just like greedy method. Some problems are solvable, but not all. लेकिन हर problem optimization problem आप solve कर सकते हो dynamic programming से. That is what I am saying. ठीक है? So this is just a correlation to show the difference or distinction between greedy method and dynamic programming. So there are two important elements of dynamic programming. हम आगे बढ़ेंगे अब. Yeah. For solving problem based on dynamic programming, there are two elements, two characteristics. मतलब कोई भी प्रॉब्लम अगर आप सोचना है कि डायनेमिक प्रोग्रामिंग से हम सॉल्व कर सकते या ना हो, तो ये दो इंपॉर्टेंट कैरेक्टरिस्टिक है, दो इंपॉर्टेंट एलिमेंट्स है विच शुड बी सेटिस्फाइड. व्हाट आर दे? व्हाट आर दे? कैन यू प्लीज राइट डाउन एंड टेल मी व्हाट आर द टू एलिमेंट्स दैट should be satisfied to solve a problem based on dynamic programming. Come on, what are the two elements? हमने ऑलरेडी पिछले स्लाइड्स में लिखा, बट नाउ वी आर फॉर्मलाइजिंग इट, और मैं एक एग्जांपल से भी उसे प्रूव करूंगा, so that we can continue with our main objective of solving the problem using this. Yes, Satyam Vinayak, you are very correct. One is optimal substructure property. The problem should exhibit this optimal substructure property. देखिए कॉमन टेक्स्ट बुक से कन्वेंशन ये है, दे यूज द वर्ड ऑप्टिमल सबस्ट्रक्चर प्रॉपर्टी. सेम थिंग साहनी टेक्स्ट बुक से प्रिंसिपल ऑफ ऑप्टिमैलिटी. बोथ आर एग्जैक्टली सेम, देयर इज नो इशू. प्रिंसिपल ऑफ ऑप्टिमैलिटी. I always prefer to use this term, principle of optimality. That means the bigger problem should be broken down into right. The bigger problem should be broken down into smaller problems. जैसे यहां पर हम आप देखिए मल्टी स्टेज ग्राफ में, मल्टी स्टेज ग्राफ टुडे my not working. This breaking up the problem of finding the shortest path from 1 to 12, I can break that into two parts. Going from 1 to this stage and then the remaining sub path की बात करेंगे हम, remaining sequence of decisions, वो है optimal substructure. मैं और example से भी बाद में बताऊंगा. So meanwhile, please have a look. I think some overlaps are happening. Okay. Optimal substructure. Optimal substructure property or principle of optimality, and the second important property, second important element is overlapping subproblems. Problems should have overlapping subproblems. To understand these two aspects, to understand what is optimal substructure and overlapping subproblems, we have a very good example, very simple example. Generally we give that example, or we take that example of nth Fibonacci number. Computing nth Fibonacci number. You know the Fibonacci series, I don't have to list out, like start from 0, 1, then next 1, next 2, next 3, 5, 8, like this it go on Fibonacci, nth Fibonacci. 0th Fibonacci number, first Fibonacci number, second, third, like that it goes. And you know very well the formula which is used for computing the nth Fibonacci number. Fib of n is given by fib of n minus 1 previous value plus fib of n minus 2. This is a recursive equation. और आपको पता है the boundary condition or the terminating condition for that, fib of 0 is 0, n is equal to 0, and fib of 1 is equal to 1, n is equal to 1. This is our Fibonacci sequence, recursion or recurrence for solving Fibonacci sequence. So if you try to write a recursive algorithm for this, then how does it look like? Come on, I'm just eliminating this so that I can write the recursive procedure here for your convenience. ये कैसे लगेगा? यहाँ पे हम simple algorithm लिख लेंगे, recursive algorithm for this implementation. So I will call it as algorithm fib of n. So I would say like if n is less than or equal to 1, I would say return n. Else, I would say like for example a is equal to fib of n minus 1 and b is equal to fib of n minus 2, and I would say return a plus b. That's all. This is a regular recursive implementation. This is a regular recursive implementation of nth Fibonacci number, right? If you implement this in a recursive mode as we have written here, can anybody tell me what will be the time complexity of this? Come on. What will be the time complexity of this? Anybody? Yes, Bhagwadari, you are coming after a long time, maybe few days. Prashant Prabhakar, 2 power n. How do you say it is 2 power n? Exponential, order of 2 power n, very correct. But how? How do you say it is order of 2 power n? We can show it. We can show it by taking a simple example. See here. If I want to calculate fib of 5, fib of 5 will be computed in terms of fib of 4 and fib of 3. Fib of 4 again will be computed in terms of fib of 3 and fib of 2. Fib of 3 again will be computed in terms of fib of 2 and fib of 1. Fib of 2. For just for understanding purpose, I'm showing the full tree so that you have clarity of understanding. I'm writing here in short wherever possible because यहाँ space नहीं है. So fib of 1, fib of 0. Fib of 2 is again fib of 1, fib of 0. Fib of 1 directly this base condition, right? So fib of 1 is base condition. Fib of 2 again you can write like fib of 1, fib of 0. This thing, right? So if you talk in terms of general value, like n is computed in terms of two subproblems n minus 1, n minus 2. See the previous algorithm. N minus 1 will be computed in terms of n minus 2 and n minus 3. This will be computed in terms of n minus 3 and n minus 4. So like that it goes. Further if you want. Okay, very good Bhagwadari, no problem. N minus 3, n minus 4, like this goes. तो इसकी टाइम कॉम्प्लेक्सिटी जब आप डिटरमिन करोगे, द टाइम कॉम्प्लेक्सिटी व्हेन यू ट्राई टू डिटरमिन, सी फॉर द फर्स्ट सब प्रॉब्लम, इफ यू सी द एल्गोरिथम अगेन, एल्गोरिथम, right, when n is greater than 1, I come here, I make this call, so time for this plus time for this plus time for making this computation, which is a constant. So essentially I can say like some constant time c, right, for solving this problem plus the time taken for this problem plus this problem. लेकिन जब आप ये problem लेंगे, इसी तरह इसका भी time लगेगा c, इसका भी time लगेगा c, returning the sum of these two, right, that is c. Time for this again will be c, again will be c, again will be c, again will be c, like that. At every level of recursion, the time at the root will be c. So that means if you assume, see, this will go into more depth, this will get into less depth, because this is getting decreased by a factor of 2, n minus 2, n minus 4, maybe n minus 6, like that it goes. And this is going in linear order, n minus 1, n minus 2, n minus 3, next level per n minus 4. So this will go into more depth, up to n calls, like n minus 0, n minus 1, n minus 2, n minus 3, like that. So if without losing any generality, if you assume a symmetric pyramid for this, so I can take that the total sum at this level is c. At this total computational cost is 2c, the total computational cost here is 4c, next level it will be 8c, and like that it goes up to what? Up to here n minus k. So here I would say 2 power k, right, into c. K is the maximum depth, n minus 1, 2, 3 up to n minus k, such that you can write n minus k become equal to 1, the boundary condition, where I would say k is equal to n minus 1. So if you take the sum of this, the time complexity can be written as c into sigma 2 power I going from, for example, 0 to k. 0 to k is nothing but n minus 1. So if you take the order of this is nothing but c into 2 power n complexity. So therefore this is order of 2 power n, exponential time. ठीक है, ठीक है. This is exponential time complexity. This regular recursive implementation of Fibonacci is basically taking exponential time. Okay? Is taking exponential time. So the question is, if you see the diagram here, your observation should make a catch here, your eye should make a catch here that there are many repetitive subproblems. Like for example, you see fib of 3 is being computed again here. तो जो पाथ हमने जो रिकर्शन ट्री हमने यहां पर कंप्यूट किया, सेम थिंग आर बी गोइंग टू रिपीट इट हियर और नॉट? डोंट यू एग्री दैट इज वेस्ट ऑफ टाइम? तो अगर मान लीजिए हमारे पास कोई मैकेनिज्म होता जिससे इफ यू वुड हैव स्टोर द वैल्यू ऑफ फिब ऑफ 3 हियर, फॉर एग्जांपल, वट एवर वैल्यू व्हेन वी गॉट, लाइक फिब ऑफ 1 इज गोइंग टू रिटर्न 1, फिब ऑफ 0 इज गोइंग टू रिटर्न 0, वी आर गोइंग टू ऐड दिस एज द वैल्यू ऑफ दिस इज 1, दिस इज 1, 1 plus 1 वी रिटर्न दिस 2. जब हम पहली बार फिब ऑफ 3 कैलकुलेट किया और स्टोर कर लिए वैल्यू, फिब ऑफ 2 पहली बार जब कैलकुलेट किए स्टोर कर लिए वैल्यू, राइट, दीज वैल्यूज इफ यू आर एबल टू स्टोर समवेयर इन द टेबल, टैबुलेट इट, then reuse it rather than recompute, definitely I can collapse this vertex. I need not generate this. ये generate हम नहीं करेंगे अगर हम ये store करेंगे. That is going to definitely, right, that is going to definitely optimize the time. उसी तरह ये this path would also have been collapsed if I reuse the value of fib of 2. That is the basic core idea of trying to tabulate or trying to optimize, right? So this is the meaning of substructure, optimal substructure. Optimal substructure का concept क्या है यहाँ पर? Fibonacci sequence अगर आप देखेंगे sequence, we are expressing the problem in terms of subproblem. Optimal substructure property is satisfied, and secondly, overlapping subproblems also is being proven over here. So therefore, both the properties of substructure and overlapping subproblems are being obeyed by Fibonacci sequence. So therefore, this implies that this particular problem can definitely be solved using dynamic programming. This particular problem can definitely be solved using dynamic programming. जब आप solve करोगे dynamic programming से, I would like to make a mention. देखिए आप यहाँ पर एक simple diagram है जो बता रहे हैं. This is with regular recursion. एक diagram है regular recursion. So fib of 3 we are exploding, fib of 2 and then fib of 1. Fib of 2 is fib of 1, so overlapping subproblems. So if I compute fib of 1 for example only one time, then fib of 3 can make that computation and close. So now the resultant will not be a tree structure, resultant will become a directed acyclic graph. Directed acyclic graph. और एक भी एक डायग्राम है मेरे पास, मैं आपको बताऊं. Just a second. Look at this. This is also a slightly bigger picture showing the recursion structure of 7th Fibonacci number, whose value is 19, where I am showing the subproblems with blue color here. This blue color, right? Feroza color bolenge aap, not exactly blue. So this is overlapping subproblems in the recursion tree. Overlapping subproblems. And the green nodes are nothing but the boundary conditions. The green nodes are the boundary conditions. Terminating conditions. Fib of 1, fib of 0. So you see, and the white nodes are the actual computation. These are the actual computations. तो अगर ये actual computations हम एक बार कर लेते और result store कर लेंगे, तो ये जितने भी blue nodes है, we would have avoided. We would have been able to avoid it. That is the main crux of understanding the overlapping subproblem with optimal substructure property. तो अब हम देखना ये है कि कैसे करेंगे, right? So there are two approaches of solving problem based on dynamic programming. Please observe. There are two approaches of solving dynamic programming to apply the concept of overlapping subproblems and optimal substructure property. There are two approaches of solving problem based on dynamic programming. The first approach is called top-down approach. First approach is called top-down approach. And the second approach is called bottom-up. Bottom-up. I would like to also make a mention that top-down approach is called memoization. We are going to memorize the values. Store them in table and reuse them whenever required. सबसे पहले जो भी हम एक सब प्रॉब्लम देखेंगे जिसका सॉल्यूशन चाहिए, हम पहले टेबल में देखेंगे कि क्या वो वैल्यू डिफाइन है, ऑलरेडी हमने किया है कंप्यूटेशन. अगर किया हो तो डायरेक्टली यूज कर लीजिए, अगर ना किया हो तो कंप्यूट कीजिए. अभी मैं बता दूंगा आपको फिबोनाची यूजिंग मेमोराइजेशन कैसा होगा. फिर बॉटम अप, इट इज ऑल्सो कॉल्ड टैबुलेशन मेथड. तो यहां पर आप बॉटम अप फैशन में सॉल्यूशंस को बिल्डअप करेंगे, स्मॉलर प्रॉब्लम्स को सॉल्व करेंगे और लार्जर प्रॉब्लम्स का सॉल्यूशन लेके आएंगे. दैट इज कॉल्ड बॉटम अप अप्रोच. So generally this is implemented in a iterative mode, iterative fashion, and this is implemented in a recursive fashion. ये difference है दोनों में. Is generally implemented in a recursive fashion. In a recursive fashion. Similarity between dynamic programming and greedy method. People often ask this in the interview. What is the similarity between dynamic programming and divide and conquer? The similarity is that both of them divide the problem into subproblems. Again, I'm telling. The similarity between dynamic programming and divide and conquer is that both of them divide the problem into subproblems. Okay? Difference is that in the case of divide and conquer, when we solve problems using divide and conquer, we will have always independent subproblems. There is no question of overlapping सब प्रॉब्लम्स. आप ले लीजिए मर्ज सॉर्ट या क्विक सॉर्ट या बाइनरी सर्च या और कुछ भी हो, ओवरलैपिंग सब प्रॉब्लम्स नहीं रहेंगे ऑन डिवाइड एंड कॉन्कर. Whereas overlapping sub problems should be there for problem solvable with dynamic programming. These are fundamental difference. Secondly, difference between greedy method and dynamic programming. Greedy method works in a stepwise manner by appealing to principle of local optimality. Whereas in dynamic programming, right, we arrive at the decision, we make the decision by applying the principle of optimal substructure or principle of global optimality. Principle of global optimality states that whatever the initial state or whatever state you are and your decision is, the remaining sequence of decision should be optimal. The concept of remaining sequence of decision does not arise in greedy method. That's it. This is the comparison between these three approaches. To show you the implementation. So first I will have a small recap of what we have seen so far, and then I will show you the implementation of Fibonacci nth Fibonacci number computation using memoization and using tabulation. Both how ये दोनों कैसे दिखेंगे हम देखेंगे, फिर उसके बाद हमारे प्रॉब्लम मल्टी स्टेज ग्राफ पर आएंगे हम. देखिए आप. So it is an optimization technique. Which one? Dynamic programming. It is an optimization technique used to solve recursive problems more effectively. It is mainly done by finding if there are any repetitive subproblems. यही मैं बता रहा हूँ आपको. This is the main characteristic of it. And if so, compute it only once and store the value. By doing that, we can avoid recomputing repetitive of times. So that is the main characteristic of it. The final result is we get an optimized solution with a polynomial. Generally polynomial time complexity से आता है most often, even though that is not necessary. क्योंकि बास प्रॉब्लम्स है जैसे ट्रैवलिंग सेल्स पर्सन प्रॉब्लम, अगर आप डायनेमिक प्रोग्रामिंग से भी सॉल्व करोगे तो इसकी टाइम कॉम्प्लेक्सिटी एक्सपोनेंशियल होगी इंस्टेड ऑफ एक्स. ठीक है, नेक्स्ट. ये बहुत इंपॉर्टेंट स्टेप्स है. देखिए आप, when to use, generally students पूछते हैं when to use dynamic programming. So I have written down the steps for your convenience. If the problem can be divided into sub problems. तो यहाँ पर ही मैंने कहा था इसलिए आपके कि difference between divide and conquer and dynamic programming, दोनों में भी आप divide करोगे sub problems, लेकिन distinction मैंने कहा. If we can implement a recursive solution, and there are repetitive sub problems, overlapping sub problems, the solution could be done, as I said just now, using memoization or using tabulation, either top down or bottom up. ये नोट्स आपको शेयर आपको मिल जाएंगे तो आपके लिए काफ़ी आसानी रहेगी टू रिकैप एवरीथिंग. ठीक है, नेक्स्ट. मेमोराइजेशन क्या है? पॉइंट नंबर 1, दिस इज डन इन रिकर्सिवली एंड इट फॉलोज ए टॉप डाउन अप्रोच. अभी बताऊंगा मैं आपको कैसे टॉप डाउन होगा. इन दिस टेक्निक वी आर स्टिल सॉल्विंग द प्रॉब्लम रिकर्सिवली, दैट्स व्हाट आई टोल्ड यू, बट दिस टाइम वी आर गोइंग टू कैश स्टोर. कैश मीन्स स्टोर the result of each subproblem in order to solve it, in order to avoid solving it again, in order not to solve it again repeatedly. ये है essence of top-down approach or memoization. When we encounter the same subproblem that we did before, we just access its result from the cache instead of recomputing it again. बहुत clarity से लिखा गया है यहाँ पर with regard to what is memoization. So my dear students, hold it as notes so that you can refer at future time whenever you are going for interviews. To make things clearer, so let's implement brute force of Fibonacci and then the other approach जो मैंने कहा अभी बताऊंगा मैं. Like for example, you consider this. This is the memoized implementation. Memoized implementation of nth Fibonacci number, Fib of n. Look at that. यहां पर हम एक टेबल ले रहे हैं जिसका नाम है mem. It's a simple array. 1 to n, you can say. Array of size n elements. So look at the implementation. If mem of n, like for example, I am computing fib of 5. So what will I do? I will take a simple array. Kindly see on board. We'll make a simple trace. So this is my array mem. I want to compute fib of 5. So fib of 0, 1, 2, 3, 4, 5 like this. Initially, no values of any fib will be known to me, so therefore I say undefined, infinity like undefined, or dash like undefined. Will put undefined, 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 undefined initially. Everything is undefined. Look at this. So I start with mem of 5. Here I will say fib of 5. I will write like fib of 5. Mem fib of 5. Right? I come n. So mem of n is undefined. Yes. So there what you are saying, if n is less than 2, result is equal to n. Right now n is not equal to 2. Else result is equal to mem fib. So we are, because we don't know, we make a recursive call. So I'm saying fib of 4 राइट, प्लस fib ऑफ 3, ये तो हम बाद में करेंगे. अब fib ऑफ 4 पे आ गए आप. fib ऑफ 4 is also undefined, so that will make a call to fib of 3. ठीक है. Then fib of 3 will make a recursive call to fib of 2. अभी भी हम अभी undefined है पूरे. So therefore now I will now observe fib of 1. ये कैसे मेमोराइजेशन से वर्क कर रहा है, प्लीज ऑब्जर्व. fib of 1. Now what happens? Fib of 1 is also undefined. If n is less than 2, yes, 1 is less than 2, result is equal to n. So result हमारे पास आ गया n में. हम यहाँ else part में नहीं आएंगे. Mem of 1, because n is 1. So mem of 1 we are writing result. So what is result? Result is 1. तो मतलब यहाँ पर ये undefined value कट हो जाएगी. उसकी जगह हम यहाँ पर define कर देंगे first time 1. So I'm computing the value of fib of 1 for the first time, and then I return the result, right? Fib of 2 का result यहाँ पे है, fib of 1. Then we make a call fib of 0, right? So this is returning here the value 1, right? With recursion. So fib of 0. So when I make a call fib of 0, fib of 0 is also undefined. N is less than 2, yes. Result is equal to 0. So that is stored in mem of 0. So यहाँ पर 0 store हो जाएगा first time. So this is going to return for the first time fib of 0 in 2. So now I'm storing the result. Fib of n minus 2 I got 1 as got 1. This is 0. 1 plus 0 is returned in result for when I make the call to fib of 2. So in mem of 2 I'm storing the result, right? Mem of 2, because this is the call. Mem of 2 I'm storing the result as 1. So this is being stored as 1. This is being stored as 1. Right? So when my fib of n was 3, I made a call, I got the value of fib of 2 as 1. Now I work for this, that there is second call, that is nothing but fib of 1, 3 minus 2, 3 minus 2 and then 3 minus 1. So 3 minus 1 is 2, fib of 2 is over, fib of 1 we are making a call. So now when I make a call fib of 1 on the right hand side, for example, fib of 1 is already defined, look at this. So I come over here, return mem of n. So fib of 1 is 1. So I return 1 to this. And fib of 2 return 1 to this. So therefore 1 plus 1, it is going to store in fib of 3 the value 2. So this is going to store the value 2. Similarly, so fib of 3 is returning the value at 4 as 2. Now the other call which I am going to make for fib of 4, look at this, this is fib of 3. So once I make a call, I check is fib of 3 defined? Yes, fib of 3 is defined as 2. So directly it is going to return 2 here. So in fib of 4, we are going to write like 2 plus 1, 3. So 2 plus 1. So here we are going to write it as 3. Then finally like that, when I come here, fib of 5, we make a call fib of 3 here, right? Fib of 3 is also defined. Fib of 3 is also defined as 2. So this is going to return basically like fib of 4 is 3, right? 2 plus 1, 3. This has returned 1 and this was 2. So and this is returning fib of 3 as 2. So therefore fib of 5 we write it as 5. 3 plus 2, 5. This is the way. So that means we have not evaluated this, we have not evaluated further this, we have not evaluated this. That means we made one call to fib of 5, we make one call to fib of 4, we evaluate fib of 3, 1, fib of 2, 1, fib of 1. So therefore this is linear. That is why we estimate the time complexity of this is order of n. So this implementation has time complexity of order of n. Can you please tell me what will be the space complexity of this implementation? यहाँ पर हम stack use कर रहे हैं recursive call से. So what will be the space complexity order of dash? Let me see whether you know it or not. Come on. What is the space complexity of memoized implementation of nth Fibonacci number? Space complexity. Very correct. Order of n. We require number of recursive calls for this. It's a linear recursion, so therefore order of n. The space complexity is also order of n. It is a memoized implementation. Very correct, very correct. Next, what is the tabulated implementation? ये बहुत simple है. What is the tabulation implementation? Look at this. This iterative approach. This follows iterative method. Iterative and bottom up. It solves the original problem from sub-problem in a bottom-up fashion. In this approach, we are solving the problem iteratively. We do this by filling a table with the results of the sub-problem from the bottom till we reach our final result. So अगर Fibonacci का implementation आप tabulation basis पर देखोगे, this is how it looks like. So here also I'm using a table by name mem, linear one-dimensional table, maybe 1 to n you can write. Right? Look at that. Mem of 0 is equal to 0, mem table of, this is not recursion, look at this, this is tabulated Fibonacci. Mem of 0 is 0, mem of 1 is 1, there is no recursive call. For I is equal to from second number, because fib of 0 is defined, fib of 1 is defined, fib of 2 onwards we have to go up to n and we have to return mem of n, nth Fibonacci number. तो हम क्या कर रहे हैं, mem of I directly is equal to mem of I minus 2. जैसा फॉर एग्जाम्पल अगर आप ले लो I की वैल्यू 2, तो ये बन जाएगा mem of 0, हाँ mem of 0 ऑलरेडी टेबल में है, mem of 1, हाँ mem of 1 भी ऑलरेडी है, तो therefore mem of 0 plus mem of 1 which is 0 plus 1, mem of 2 will become 1, that's it. फिर उसके बाद आएगी बात mem of 3, mem of 1 भी डिफाइंड है, mem of 2 भी 0 भी सॉरी mem of I 3 जब होगा I की वैल्यू 3 होगा तो ये होगा 1, ये होगा 2, तो दोनों भी वैल्यूज टेबल में है, so you get, so climb up, so like that in a bottom up fashion you go. And very clear, the time complexity of this implementation is how much? Very simple, this is also order of n. This is also order of n. Is it not? Check it. This is repeating for n minus 1 times, order of n. और इसकी space complexity कितनी होगी? Come on. What is the space complexity of this? Time complexity is order of n. Space complexity is also order of n. Correct? Why? Because I need table for this. I need space for this table. जैसा पिछले बार में भी आपके पास टेबल था, यहां पर भी आपके पास टेबल होगा. पिछले बार में स्टैक भी थी आपके पास, स्टैक स्पेस भी थी और टेबल भी था. यहां पर स्टैक स्पेस नहीं है. दैट इज एडवांटेज ऑफ दिस अप्रोच. सो दैट इज व्हाई द एडवांटेज ऑफ आइटरेटिव अप्रोच इज दैट आई डोंट रिक्वायर स्टैक स्पेस. मेमोइज्ड अप्रोच हमेशा रिकर्सिव इंप्लीमेंटेशन होगा, वहां पर वो ड्रॉबैक होगा कि आपको स्टैक स्पेस लगेगी. दिस इज द डिफरेंस बिटवीन द टू अप्रोचेस ऑफ सॉल्विंग प्रॉब्लम बेस्ड ऑन डायनामिक tabulation based on memoization. So the choice is yours. अब फिर एक बार देखेंगे कि जनरली स्टूडेंट्स पूछते हैं क्वेश्चन कि when should I use tabulation, when should I use memoization, because both the approaches top down and bottom up, both of them will give you the correct answers. So when should I use top down, when should I use bottom up? के लिए भी एक सिंपल स्लाइड है मेरे पास, शायद आप देख सकते हैं. Should I use tabulation or memoization? Please read it. Should I go for tabulation or should I go for memoization? Look at this. If the original problem requires all sub-problems to be solved, tabulation usually outperforms, matlab it will be better by a constant factor. This is because tabulation has no overhead. अभी मैं आपको बताया था, has no overhead of recursion. ये point आप हमेशा remember कीजिए. Otherwise, if only some of the sub-problem needs to be solved, not all, for the original sub-problem, then memoization is preferable since the sub-problems are solved lazily, that is precisely the computations needed are carried out. Very precise computations are carried out. Anyway, the choice is yours, nothing to worry about which one to use. The most often we use bottom up approach because of no requirement of stack space overhead, no need for implementing it recursively. So that is the paradigm, the approach of solving the problems of 3D method of dynamic programming. तो यहां पर मैं समराइज ये कर रहा हूं कि for dynamic programming, so basically evolves on the lines of brute force. लेकिन हमने कहा variation from brute force is that it is not going to explore all the paths. It will curtail those decision sequences from where there is no possibility of getting optimal solution. Second, it will tabulate, memoize the results, tabulate so that reusability concept can be used rather than recomputation. Secondly, it appeals or makes decisions by appealing to principle of optimality. मतलब जो भी प्रॉब्लम में ऑप्टिमल सबस्ट्रक्चर या प्रिंसिपल ऑफ ऑप्टिमैलिटी एप्लीकेबल होगा, ऑप्टिमल सबस्ट्रक्चर या प्रिंसिपल ऑफ ऑप्टिमैलिटी होगा, तो आप डायनामिक प्रोग्रामिंग से सॉल्व कर सकते हो. अपीलिंग टू प्रिंसिपल ऑफ ऑप्टिमैलिटी व्हिच स्टेट्स दैट whatever the current state or initial state and decision or the remaining sequence of decision must constitute an optimal decision sequence with respect to the state resulting from the first decision. रिमेनिंग कॉन्सेप्ट, जो कॉन्सेप्ट है रिमेनिंग सीक्वेंस ऑफ डिसीजंस का, रिमेनिंग सब पाथ या रिमेनिंग सब स्ट्रक्चर का, वो greedy method में नहीं होगा. Right? That is the point I'm trying to. Greedy method say that whatever my current state and decision are, right? Current state and available options are, greedily select the option without bothering about the remaining sequence of decision. Will they be optimal or not? Greedy method does not bother. Secondly, we said the elements of dynamic programming, the two things that should be applicable is optimal substructure property. And secondly, we say overlapping sub problems. अगर ये दो भी applicable हो, so definitely you can apply dynamic programming. कैसे करोगे? Either you apply in a top-down fashion or bottom-up fashion. This is the summarized discussion of whatever we discussed so far. Bottom-up or top-down. Memoization or tabulation, that's it. और कब memoization करना है और कब tabulation करना है वो भी मैंने पिछले स्लाइड में रख दिया है. नोट्स आपके लिए आपको मिल जाएंगे. आप वहां पे हमेशा you keep it with you. What exactly is substructure property, what exactly is overlapping subproblem, and when should I use which type of approach, that also is there in the handout, you can take it. So this is the summarization. So based on this, हम क्या करेंगे? We will try to explore and find out can we solve in the remaining time the multistage graph problem. I will just take the multistage graph problem again, and we'll try to explore can we find the solution, recursive solution, can we report, can we find it? We'll see it here. Okay. So for this graph, now I will clean this. How do I prove that it has overlapping subproblems and it obeys optimal substructure property? And based on that, how do we arrive at the optimal solution? That we will have to explore. So for that, I would like to first tell you that the graph is represented, please observe, the graph is represented by means of cost adjacency matrix. ये बहुत ज़रूरी है. ये बहुत ज़रूरी है. How are we going to represent the graph? I hope you know already the representations of graph, cost adjacency matrix, n by n matrix. The value of n here, the value of n here is 12. 12 by 12 matrix. This is I and this is j. Cost of ij, like 1 to 1 there is no edge, 1 to 2 the edge cost is 9, 1 to 3 the edge cost is 7, and like that it goes. So therefore here I write Cij is equal to edge cost. Cij is nothing but edge cost, cost of the edge. But what do we want? We want path cost. We want path cost. From where to where? From vertex S to vertex T. तो एक प्रॉपर्टी है, कैरेक्टरिस्टिक है डायनेमिक प्रोग्रामिंग के प्रॉब्लम जब आप सॉल्व करेंगे. मैंने पिछले मेरे स्लाइड्स में भी लिखा था कि यू आर गोइंग टू रिप्रेजेंट द सॉल्यूशन टू द प्रॉब्लम बाय मींस ऑफ ए रिकर्सिव फॉर्मूला. ऑलवेज इज अ प्रॉपर्टी, राइट? आई विल शेयर द पीपीटी, द प्रेजेंटेशन, द पीडीएफ आपको मिल जाएगी. इट विल बी देयर इन द पीडब्ल्यू ऐप, यू कैन चेक. और यूट्यूब चैनल में भी रहेगा. So what I am trying to say, when you are solving a problem based on dynamic programming, the solution to that is represented recursively. और ये बहुत interesting aspect है. There were questions in earlier papers based on GET. आपको एक problem describe किया जाएगा, multiple option दिए जाएंगे in the form of a recursive formula और पूछा जाएगा कि कौन सा formula among ABCD represent the solution to dynamic programming. और ये जो formula हम derive करेंगे ना, it will be based purely on प्रिंसिपल ऑफ ऑप्टिमैलिटी और ऑप्टिमल सबस्ट्रक्चर प्रॉपर्टी. वो कैसे करेंगे, दैट इज वेरी इंटरेस्टिंग. और मैं चाहूंगा मैक्सिमम जितने प्रॉब्लम्स कोशिश करूंगा आपको ये सिखाने की कि ये फॉर्मूला हम कैसे डिराइव करेंगे, ये कैसे डिराइव करेंगे. हर फॉर्मूला का एक अपना एक कन्वेंशन होगा. जैसा कि मल्टी स्टेज ग्राफ में जनरली वी अज्यूम लेट कॉस्ट ऑफ आई जे रिप्रेजेंट कॉस्ट ऑफ द पाथ from vertex J present in stage I. to reach the destination vertex. Look at that. ये अंडरस्टैंडिंग बहुत जरूरी है. Cost of ij represent the cost of the path from where? From vertex j. j is vertex number. Where is vertex j? Present in stage I. आप अगर देखेंगे तो हर वर्टेक्स एक स्टेज में है. दिस इज स्टेज 1, स्टेज 2, स्टेज 3, स्टेज 4, स्टेज 5, लाइक दैट. हर वर्टेक्स अपनी एक स्टेज में है. तो कॉस्ट ऑफ आई जे रिप्रेजेंट कॉस्ट ऑफ द पाथ फ्रॉम वर्टेक्स जे प्रेजेंट इन स्टेज आई टू रीच द डेस्टिनेशन वर्टेक्स टी. डायग्रामेटिकली आपको अगर मैं समझा दूं, इट लुक्स लाइक दिस वर्टेक्स जे. वेयर इज इट प्रेजेंट? स्टेज आई. एंड इट रिप्रेजेंट द कॉस्ट ऑफ द पाथ टू रीच वर्टेक्स टी. This is actually cost of ij. Is the cost of ij. तो ये जो फॉर्मूला है कॉस्ट ऑफ ij का, we have to minimize this cost, right? So minimize this cost. Cost of ij is equal to, I will write like minimize this cost. So minimize of what? Minimum of what? ये कैसे derive करेंगे? So this minimization on the right hand side will be purely governed by, will be purely decided by optimal substructure or principle of optimality. वो कैसे करेंगे हम? तो माय डियर स्टूडेंट्स, ये यहाँ से मैं अब डिस्कशन आई विल वांट टू टेक इट इन द नेक्स्ट क्लास, बिकॉज आज एक 10-15 मिनट पहले मुझे छोड़ना है क्लास. आई हैव सम इम्पॉर्टेंट पर्सनल वर्क, सो दैट्स व्हाई आई वांटेड टू स्टॉप नाउ. नेक्स्ट क्लास में मैं यहाँ से कंटिन्यू करूंगा. आई विल टीच यू, आई विल शो यू हाउ टू डिराइव द फॉर्मूला रिप्रेजेंटिंग द सोल्यूशन टू द प्रॉब्लम ऑफ मल्टीस्टेज ग्राफ. यूजिंग दैट फॉर्मूला हम सॉल्व करेंगे प्रॉब्लम. फिर और एक भी प्रॉब्लम लेंगे, रिलायबल सिस्टम डिजाइन, उसका भी फॉर्मूला कैसे डिराइव करेंगे आपसे डिस्कस करेंगे. फिर और एक भी प्रॉब्लम है LCS, वो भी हम देखेंगे, राइट. सो आज की क्लास इतना ही. मैं एक 10 मिनट पहले छोड़ रहा हूं क्योंकि एज आई टोल्ड आई हैव सम वर्क आई हैव टू अटेंड. वी विल कंटिन्यू फ्रॉम हियर इन द नेक्स्ट क्लास, वेयर आई विल शो यू solution to multi-stage graph, solution to longest common subsequence, and if time permit, definitely I will cover up reliable system design also. Okay, thank you very much. Take care. Good night.